Good afternoon, ladies and gentlemen, and welcome today to this MasterSeries webinar. Today we're looking at masonry design and how the latest version of the Master Key Masonry software is able to design masonry walls far more economically than normal and with less materials and less headaches. So I'm going to start. And I'm just going to take you through, for those of you who are not familiar with either the MasterSeries or the Masonry at all, a little PowerPoint presentation, which will just give us in 2 minutes an idea of where we are. The MasterSeries. So our company is called Civil and Structural Computer Services, but the products are called the MasterSeries, and we've been going for over 30 years. And we've been doing multi-material software for a long time, and we are wholly a UK company. We have 3 ranges of products. Our big building design suite, which we're not going to be looking at today. We then have our smaller PowerPad suite for small practices and sole practitioners, or as an additional tool in the larger office. Very useful. And some of the masonry will be covered today in this, but we'll be looking at the full version of the masonry today. And then we have the custom suite, as I call it, where you can configure what you've got. So if you look at the custom suite, we have 4 different types of analysis. We then have all these add-ons that you can add in, including dynamic and seismic and wind and things like that. And then we have our design modules. And the reason we do this as a modular system, is so that you only purchase what you need. So back onto this screen and off we go again. So as you can see, masonry down at the bottom here is one of these standalone products, so that you can take that and nothing else and use that. And here we can see the interconnectivity of all the different applications that are the integrated systems of the core MasterSeries. But as I said earlier, today we are looking at this standalone masonry program. So I'm just going to press escape, come back out of that, and we're going to go into the MasterSeries. So I'm going to take you from the very start. So I'm going to go up and down to the M's, and you'll see we have MasterSeries. Expand this group, and you'll see now we have the main MasterSeries. We also have facilities for help and other things as well, but it is this core one MasterSeries, and we're still running 2006. So as I come in with my boilerplate, we are running 2016-15 from the 27th of March. Now, users don't panic. The latest issued version is from the 9th of March. I am just testing out a slightly more up-to-date version before we push it out onto the web in the next day or so. So what we see is that we have a webinar today. And we did one the other month on connection design, before that in concrete. So we have a lot of access here to information, but we are only looking at masonry, so into our designer suite and straight in to the masonry design program. So masonry design. So here we go, some simple different files that we've been playing around with, and I'm going to choose this one. And just so that we come in like a stampeding horse, this is where we're going to get to. We're going to be putting in a wall with, in essence, 4 openings, some line loads across the wall, a wind post to try and make it work. We have loading from above that is concentric. We have some point loads that are coming down onto the wall, and they'll be spread through. So we're looking at all of that information. So let's skip past all that and get into starting the most basic wall. Simple cavity wall. And when I occasionally get into doing tech support, people would ask me things like, well, how do I do a single skin leaf? Well, very simply, you just tell it that it's not cavity. You tell it that you want piers. No, I don't want those piers. You tell it that you want it to be one-way spanning, and I can see if this wall, which is 5 meters by 3 meters, is one-way spanning, we have a problem. Its capacity is over by 22-23%. And I can see that, and I knew that because the screen was blue, so we're always getting confirmation as to whether we have a problem or success. And we will see when we put that back to two-way spanning, the screen goes white, there's no problems, and our unity values drop down. So if I was to take off some of this fixity, so at the minute we have that traditional designation of cross-hatching means fully fixed. I'm going to make the two sides pinned on each side, and we can see that we've gone from 0.45 to 0.59, so we've lost a bit of our capacity. I'm now going to make the top pinned as well, and we'll see that we're going up to 0.72 as our capacity. If I was to make this totally free, now we are at a 9% failure in this wall. What can we do? Well, very simply, we can come along and we can increase the thickness of the wall. That's the simple solution, and is not the popular solution. If I did need to have this free for whatever reason, I have other ways of making it stronger. Obviously, I could ensure that this up here is also fully fixed. Or I could turn around and say, well, actually, it's not fully fixed, but it's definitely a lot better than pinned. So let's put about a 25% fixity in, and that's giving me 1% failure. Okay, I'm going to say 30% fixity, and now the wall is working. Obviously, these degrees of fixity all come from the simple equations, and it's up to yourself to decide how fixed it is. I would never be considering it to be 90% fixity, because it's either fixed or it's not in that respect. But 10, 20, 30% fixity when you're coming into a wall and shot fixed against it and there's virtually no movement, absolutely. Well, normally with shot fixed, if there's no movement, you take it as fully fixed. But if they do have some backing material, then you can take a degree of fixity just to get you that bit more of restraint. And I'm going to take that out. So I just click on that image again, and that's it free. No thank you. That's us back to my pinned. Okay, so fixing it was one solution. Obviously another solution would be to shorten it. We can't do that. What we can do is to think about the materials, and up to a certain level we can improve the strength, but once you go above 10.4s is 9%, 17 Newton blocks is, and this is on the inner leaf, is as far as you can go. There's axial strength increase, but there is no flexural strength increase. We could turn around and change our class to make our class a bit better, and we're down to 2% overstressing, and we could possibly go for it in both execution and control, but that's not really applicable. I'm happy with execution class 1. So let's look at the outer leaf. Clay bricks 7 to 11% or 12%. If I went to the denser 7% mortar, then I don't have that problem, and now my wall works. So I have all the different standard size classifications of bricks and blocks. So if I'm going to my bricks, I can then see my standard strengths of bricks. Now we do have the ability for you to come in and input your own axial load. So you can turn around and say, well, actually, this has an axial load of 12.5 from test results, and not been released, but we're just testing it out this week. We have allowed you to input your FXK1 and FXK2 for your bending. Bear in mind that we are using the nomenclature of the Eurocode EN 1996, or Eurocode 6 is what we are designing to. So we do have that facility to go in and create your own material strength. Speaking of design codes, it's probably worthwhile at this point in time to say that we can design to the historical British codes from the Legacy and the 2005 edition, as well as the Irish 325 design code. Under the Eurocode, we are designing to the 2005, and we're using the UK National Annex. If I was to change this to the defaults, we would see that suddenly the moment capacity fails, because a couple of these values change for the Eurocode norm, the more conservative. But in the UK, we are happy to reduce these slightly down, and we can obviously try and see where that change is if we're very quick and see the number that is actually changing. So it's this number here that's changing, so there's something in here that is being reduced to make it fail. So as I said, we have all these different national annexes, and you'll notice that there's 2 or 3 there that have been created by myself for other countries. So if you are working in another country, you will have your own national annex that you will wish to use for all your gamma values and things like that. And this allows you to create them and use them. I'm going back to the UK one because that's where I am based, and we'll see that this wall works. Now, that's our first basic wall. Our second basic wall is the same, but it is a freestanding masonry wall, and it is actually asking to use yield line analysis. Now, I can turn off the yield line analysis and show that the wall under the old-fashioned spread is fading by 11%. So using the old-fashioned methods of little T-stubs here for these cantilevers, I can show it doesn't work. And at this stage I'm going to bring in this new yield line analysis, and we'll see that the yield line analysis is actually now showing that we've got a 15% reserve on our wall. So our wall is actually working. We could possibly look at reducing either the width or the thickness, or even increasing the spacing of our piers to find that out. Now this is a very good time to look at this value here, and we can analyze this because we are using yield line analysis, and we are using we are looking for the most critical yield line analysis across all the possible yield lines that can form as designated by our pattern of yield lines that we generate. And if we go to a coarse one, we will see that it analyzes very, very quickly. As we come down to medium, it analyzes in 2-3 seconds, and as I go to fine, we will see that that's taking a second or two. When I'm in fine and superfine, I need to tell it to do the solving, which is taking 3-4 seconds to do the solving because it's a simple pier. So we won't delve with the piers too much longer, but we'll come to the first of the walls that I want to look at, this yielding. So this is applied yield line analysis and is applied a medium density yield line. So if I go back to coarse, you'll see it's going to give me a value of 0.553. By refining the mesh for the yield lines, we're coming down to 547, so slightly more accurate. So I've gone down to the fine, and you'll notice that I have to now click on solve because it doesn't want to auto solve with every key press because of the time taken to do the analysis, and we're seeing it taking 7-8 10, 15 maybe seconds to do that solution of the yield lines. It's still going strong there at 26 seconds. It's listed down here at the very, very bottom. And there we go. So 0.550. If I was to turn off the yield line analysis, I would see that under the old-fashioned methods, I'm getting 0.599. So there's a reasonably close correlation there between the two sets of analysis. And I just go back and it will remember my solution there. So this is probably a good time to look at all the different areas we've got in here for the input now that we've got into the more complex analysis. When you're analyzing more than two stories, it puts an onus on the load factors. If we decide to go for live load as being storage to the Eurocode, we use the 1.35 and not the 1.25 as our loading for our dead loads. In the Eurocode, you can go for this thin mortar for some of the blocks where you're actually putting in more of an epoxy resin type mortar between the blocks to glue them together, and that gives an effect on the results. I'm just going to go back just for brevity here to coarse or to medium, and then you'll see that if I do that and calculate, it's going to go from 0.547 to 0.547. It doesn't mind, it doesn't make any difference in this case. Perp end joints are filled because in some cases these wee verticals are not filled. So the perp ends of the blocks are filled, and obviously our mortar designation. So that's what we have here, and obviously we have seen the wall data. Materials, we've seen that, and we have seen that you can specify your FK and FKB, as we used to call it in the British codes, FK, FXK in the Euro codes. And we'll also notice here that we are actually dealing also with, for our blocks, not our bricks, but only our blocks, we are asked what the unit heights are. So if we were suddenly laying these blocks on the flat, we would see that there is in fact a change in the design. So outer leaf, let's come to the inner leaf. We'll see that the block ratio is 2.15. If I was to go 100, you'll see it's resizing, and it's going to give us a new value of 1 because there's 100 by that. So if I go 100 by 215, because we're laying blocks on flat, clearly I would be dealing with a wider wall anyway. We would see that this suddenly now becomes detrimental to the design because of the number of mortar joints that are in the system. So I'm going to flick those back, 215, and just quickly flick that back. And so what we can do is we can actually turn off this auto solve, so we only solve when we're finished editing. So inner material, I'm going to make that least horizontal dimension is 100 mil because it's 100 mil wide, and you can solve that then. So that's very straightforward, very, very simple. Inner leaf, loading. I have applied two loads, GK and QK, concentric from above. So this is a multi-story wall, and I've applied two concentric loads. I have also applied two eccentric loads from the current level, so a set of floor joists coming onto this wall, and obviously taking the nominal eccentricity of 20 mil. And we'll see that everything is working fine. The outer leaf is very, very similar. We're in our clay bricks. We're going to go for higher absorption and just reanalyze that, and we'll see that we're now fine, but we have changed our parameters. Again, you can change those FKs for you. There's no dimension ratio because we're dealing with bricks, not blocks. Outer leaf loading is in this case nothing, but you would have argued if you had an inner leaf loading, you probably should be having an outer leaf loading, and I'm going to make that into a GK of 15 and solve, and that should still be fine with the concentric loading. Naturally, you will also understand that we get improved strength in flexural strength due to the self-weight or concentric load weights on the wall, so we actually end up with an improved flexural strength due to the axial load, as long as it's not causing a problem with the axial itself. You'll also see that we're doing our stress analysis, and we're doing this buckling analysis at 2.5 and 1.5. So we're doing it over a width of 1 meter, and we're doing it halfway along and halfway down, and we're checking that all out for us all the time, and likewise for the inner leaf and then the design lateral loads. Concentrated point loads we will come to in a moment, but what I've also introduced already is the lateral loading. So 1.25 is our WX, our wind UDL coming onto the panel. We can also apply a triangular UDL, a wedge, onto the wall. Not used very often these days because that was introduced before we had a separate program for doing retaining walls, and it was a way of doing the stems of masonry retaining walls. We can also add in an MX and a MZ and QZ in plane loading for shear walls, so we can actually analyze if this wall had a shear of 45 kilonewtons and an overturning moment of 5, then we could see whether or not the wall with this is going to work, and it's having a wee think about the design, and we'll see it still works. It hasn't really made much difference. If it was causing us a problem, we could turn around, because most of these two lateral loads are in plane loads are assumed normally to be on the inner leaf. If we wanted to, we could turn around and say that we wanted to share it as a 50-50 contribution and apply that to the two leaves and make both of them work, transmitting the shear loads across, and it has had no effect on the analysis. We also have a non-critical. If this panel wasn't stabilizing the columns, if it wasn't loading or supporting a floor above, then it was just an infill panel, we could use non-critical and get another reduction factor. And also we have the limit that you use in the tables, and we can use those limits or go further. When we come into the yield line analysis method, we go further anyway, so this is irrelevant when we're using yield lines. So we need to move on to the next tabs, and just to save me time, I have actually created little models to do all this. So what I've now got is a laterally loaded panel, similar to before, with a 1.25 kilonewton lateral load, but we also have our concentric and eccentric internal loads. Again, no external load, but we should really put maybe 15 onto that. Let me see, wall data, inner leaf, outer leaf loading, and we should put maybe 15 onto that because that makes more sense. So we've got these UDLs on the wall. We've also got two pairs of point loads coming from beams of some sort onto the wall. And just to make my life awkward, I've also got two line loads laterally pushing against the wall. Some racking storage system is attached to the wall. For stability, we then have to allow for that in the wall. So that was one of the requests that people wanted for the 2016 edition of the Masonry, as well as our advanced U lines with openings. So if I solve all this, so we can see here that we've got a 0.9 or a 0.83 resistance, and yes, it was on the fine, and I'm going to take that back up to course, and it's just going to solve that. hopefully in about 5 seconds under the coarse, or the medium in fact. There we go. And it's just doing it twice. I think my finger is a wee bit nervous and was slipping on it. So we've got our yield line analysis, and we can see the line loads pulling everything around to, to be more like point loads because of these two line loads on the structure. But what about these here? If we scroll down, we will see that we are checking, and they are in the inner leaf, the critical compression, and we're looking at our buckling and a reduction factor due to these loads, and we're finding out whether our bearing of our point loads works, and we'll see that it all does. Now, if we go to the loading and inner leaf, I apologize, we will see that we have stipulated that we have 450 by 215 pretty standard pad stones for these two walls. If I was to say that they don't spread and put in 0 and 0 and then solve, we will see hopefully that the wall no longer works. And we will see that while the flexural strength is still fine, the screen on top is blue, and it is blue because we have no bearing enhancement, and we have 3.3 newtons with a resistance of 1.82. So we definitely need some sort of spreader. So even a 215 by 215, single digit, and by 100 by 100. So we put in a pair of engineering blocks or something to take care of that. Would that be enough? And it says yes. So we didn't actually need very, very large spreader beams. We didn't need your more traditional 1.5 foot long spreader beams. We were able just to put in a couple of engineering bricks to actually disperse that stress in that area, as long as that's detailed on the drawings for you. So we've looked at lateral loads, we've looked at vertical loads, we've looked at lateral line loads on our structure. What we now want to look at is openings. So we're back to where we started. So let's look at what we've got here. We've got our point loads. We've got a UDL on the continuous on the top on this wall. I'll probably put a similar one on the outer leaf again. I'm just going to go and make that and put a GK of 14 on that wall as well. And that should show up here in a second once it does its quick solution. So there we go. And we see we're working. So why are we working? Well, we're working because we've got a wind post. And everything is happy. If I move to the next example, we will see that without the wind post, we would need quite a substantial pier to make this work, which the client and particularly the architect are not going to be happy with. So our solution was to put in a wind post, or our other solution is to apply bed reinforcement. So pretty heavy reinforcement all the way across every other brick course, and that will make it work. But let's get back to the elegant solution. So just going to go and tell it not to auto solve. In fact, the auto solve is on a case by case basis, and luckily for me it remembers the design. So what have I done? First of all, let's look at the openings. I've stipulated 3 openings, in fact 4 openings, because this is an extension of that So we've got this wider opening on top of this. So if I was to take this and say move it up from 7.5, come back here to 9.5, you should see that it moves up. And it's just doing a calculation because it's trying to solve the solution. And you can see they're now separate from the two. So just by touching each other, it knows that they are a more simplistic opening. Single opening with complex shape. So you can use overlapping openings or touching openings to simulate, and it's just needing to update itself. Why are you not updating? So I'm just to make that 0.75. And there it's attached, and there it's updating itself naturally, automatically, and getting everything all together. So we're able to define these openings. What we're also able to do is to stipulate for each of them how they are spanning. So this one's spanning horizontally, and at the minute, so is this one. I would turn round and say that, well, yeah, it's the same opening. The other two openings, the smaller ones, are both spanning two-way, two-way being the default. You could take your first opening and say that it is bottom free, so it's top and sides but not bottom, and that would be if you're doing some sort of roller shutter type arrangement of large opening in a wall. But for a door, it's normally just going to be horizontal. You would normally ignore the top portion, but you can proportion it as you see fit. We also have the ability to say that it's a true opening. It's never closed. It's not got anything in there, and therefore there's no load coming from it. And we can do that also for all the openings in one go, which in this case would not make sense. But if you were doing some sort of fancy architectural wall, be it a freestanding wall with little viewing windows which are open, have no glazing in them, certainly that's going to be a benefit in taking off that loading off the wall. So we were able to define those openings very, very easily and very simply. The other thing we defined was a wind post, and we can see under the wind posts we can choose its distance. So it was there, 2.5. If I wanted to, I could probably put it over there and see, and at 2 meters, and see how it goes. So it's at 2 meters. There it is. We do need to reanalyze. We make it 2.25. Off it goes. Now, base, we could say the base of the panel was fixed and the top was fixed, or even the top was free. Obviously, again, for your freestanding walls, or where you're not able to get a fixity up here for whatever reason. We can also take the channel. The channel is shown on the outside surface, but naturally you would quite frequently put it in, divide the two walls up, and shot fix either side with ties to actually embed it into the wall, and you'd probably just hide it all together and skim over the top. We can also bend about the minor axis, which is done more when you're doing remedial work and trying to strengthen an existing wall that's got a problem, and you then just bolt up to it. And one other item is that we can use the plastic capacity. Now, this is a wee bit of a moot point in some respects, because when you come down and look, let's analyze and see what it says down here under the design. And what it's telling me is it's a fully restrained member, and that it is not itself failing because there's no yield lines going straight through it. So therefore it is working as an elastic component and giving the restraint it requires. So it is inherently designed, the post, in this design criteria. It's designed the post, with, in this case, a plastic capacity of 46 down to elastic capacity of 40 won't make any difference because it wasn't going to yield in that direction anyway, so it's giving us no difference in our overall unity values. What type of sections do you have? Well, I had the PFCs, I have UBs, you have circular hole sections, but be brave if you're going to use one of those. You also have angles, an interesting concept when you don't have a lot of additional strength to apply, and you have your hollow sections, square and rectangular. And obviously our PFCs. You can also slip in the split T's as well if you so desire, but I do not think that that is a most appropriate section to use. So fast, simple, easy is what this is to do. We've done the openings and we've worked all the way across on donor reinforcement. So if we were to do away with the wind post very quickly, goodbye Mr. Wind Post, and solve, we would see that it fails. I think, yeah, 1.2. If we went to reinforcement and selected bed reinforcement, then I could do the inner leaf and I could say it's actually grade 460, and I'm not going to limit it because we're doing yield line analysis. And 3 mil bars at 60, how does that help? And we're at 13% overstressed still. What about 5 mil bars? And 5 mil bars on the inner surface only will work. Now there are other compromises to go down to something like a 4 mil bar. Isn't that happy, and put in say inner and outer and solve that and see if that gets it. I'm never a great believer in putting bed reinforcement on the outer leaf because it's going to get wet. So I would far rather come along and increase this to 4.5 mil, see if that does the job. Just it does, and it's a 0.923. Now 0.923, that's interesting. Let's try the 4 mil bar. Solve. So it's giving us 0.99, but it's gone blue. And the reason behind that is because all yield line analysis is looking at possible yield line paths. And what it's telling us is that, really, when you're within 5%, we recommend that you go to as fine as possible to make sure that you've covered all the yield lines, because you may be ever so slightly out in the pattern that it has chosen, because depending on the resolution you use, you end up with quite an infinite number of solutions that it has to go through. So let's go back to our quick set and go from medium down to fine, and we'll now see that at 0.99 we solve and we're at point. It's either going to be better or worse. It's a very stupid statement, but that's the fact, and it's always interesting to see if it finds a stronger one at the higher resolution or a weaker one. As you can see, we're up to 20 seconds and we've now got it 0.976, virtually no change. And if I went to superfine, it would virtually be no change. But at superfine, we're probably well in there, and we would happily go along with that as being an acceptable solution, because that is superfine is at an exceedingly fine resolution. The resolutions are in fact based on millimeters, not percentages of the wall. So the bigger the physical wall, the more mesh points that it's considering for its yield line analysis. So that about covers it. I've gone from basic through getting more complicated and more awkward and being able to solve them all using the master key masonry design. So if I was to come back to my power pad point, sorry, and ask it to run the, we've done all that, we've seen all that. So the masonry, what are the key points in the masonry? Okay, well, walls and columns. We can switch between the BS and Euro codes. I will show you that in a second. Piers, bed reinforcements, wall openings. Those are the main physical items. As of the 2016 edition that was released, we can now handle up to 10 openings. We can have opening spans. We can have lateral line loads and up to 10 wind posts. So we can have more than one wind post in the structure, never mind more than one or two openings. And we can have these concentrated vertical loads for takedown analysis and bearing stress checks. So in summary, it is most definitely powerful, it's most definitely flexible, and absolutely this is a comprehensive program for doing masonry design. The whole MasterSeries is upgradable, so if masonry is all that you're interested in, that's all you need to purchase. And it is easy to learn. Certainly the masonry is exceedingly easy to learn, and you do have recourse to talk to any of our engineers, either directly or via web meetings, to help you with any problems you have. As you can see, this was all brought in last year for the masonry, all this E-line analysis stuff, so we're very proactive and innovative. We know of nobody using this automated E-line analysis on masonry walls in the world, and of course we are UK based. So who's using the MasterSeries? Well, you might find yourself already been listed up here amongst all these different users. And there's what some people say about the MasterSeries, and I know for a fact this one here is about our connections, and this one is about the 2016 masonry. Just able to do walls without splitting them into silly little sub-panels and making approximations. You can do what you require. If you want a 30-day trial, just go onto the website and select the 30-day trial for the masonry. If you have any questions, just send them on in to help@masterseries.com, and George, who is most expert in masonry design, and his colleagues will help you out there and answer anything you have. So I'm just going to pause everything and leave this on the screen and say thank you.